Hello guys, welcome to my YouTube channel. I am Krishna Gopal. I completed my master from ISI. In this video, I'm going to talk about the part 9 of the interview question. We have in a playlist where we are covering the part 8. In most of the videos, I discuss the 5 question. And if you are preparing for your data science interview, then please go and watch all the questions because these questions are very important. In that, many questions I face in my interview. So without wasting the time, let us start the part 9 video in which I took the 3 questions and I'm going to discuss what these questions are. So the first question is, describe the whole process to build the linear regression model in the detail. If somebody is asking this question to you, then what are the steps you should cover while you have to be explain the whole linear regression model? So first you should tell what the linear regression models do. So let me explain you in the brief the same answer. The linear regression model is used to predict the quantitative response. Linear regression try to fit the best line between the response and predictor. So once we have the best fit line, we can predict what the response with respect to the predictor. So when I say it try to fit the best line, that is it try to fit y is equal to beta naught plus beta 1 x. So now our role is to find the what is the estimate value for the beta naught and beta 1. Once we have the beta naught and beta 1, we can predict the y cap. And once we have the y cap, we can estimate the values based on the predictor. So this is the first overview you should give in the answer. What the linear regression overall do. Now the second condition is that once you have the y cap also, now you can predict the error. So the error is the yi minus yi cap. That is the error. Then you should come to the assumption. What are the assumption of the linear regression model? Because this model assumes a lot of the assumption, and if all the assumptions satisfy, then we move forward to build the linear regression. So the first assumption, which already I discussed, like there should be a linearity between the response and the predictor and can be checked with the scatter plot. Now second, what you calculate the error. So the error in the linear regression should follow the normal distribution and they are the uncorrelated with each other. The third, there should be absence of the multicollinearity, and the fourth, there is no heteroscedasticity. Then we check these 4 assumptions in our data set. Now moving forward, once all the assumptions are satisfied, now we move. Before building the linear regression, we have to define one cost function as well. So the cost function, which generally we use as the mean square error in the linear regression. So to optimize this cost function, we use the gradient descent approach to reach the minima of that cost function. So once we have these steps, now we can split the data set into the train and the cross validation, and then when we can fit the linear regression model to predict the estimated values. So here, what are the important things? First, describe what is the linear regression do. Second, what are the assumptions of the model. Third, what is the cost function. Fourth, which technique you use to minimize that cost function, and then now you fit the model. So this is the what in the brief you can explain. And this is the question which recently asked in the top product based company in the campus interview. Now so that's all you can explain. And linear regression, about the linear regression I explained in one of my earlier video, and already I have the separate playlist. You can go and watch that one. You can definitely gonna get the idea, but the process is that you can explain the linear regression in that follow. Now move to the second question. The second question is that the follow-up question which come, because you told like you use the mean square error as the loss function in the while building the linear regression model. So what is the formula for the mean square error? Mean square error is the y minus y cap whole square in the summation. So the question come now, can we use the higher degree in place of a 2, or can we use the absolute yi minus y cap whole square, both the thing. So now he is asking the 2 questions from the one question, that can he use the higher degree or they can use the absolute value. So the can I use in place of the mean square error, can I use the yi minus yi cap? Can I use like that? This function you can use, but the problem is that this function is not differentiable, and when you use the gradient descent while building the linear regression, you need the cost function should be a differentiable function, or the loss function should be a differentiable function, but this function is not a differentiable function. So to reduce this complexity, we use the square error. We use this square error. Now the another thing what he is asking, can we use the higher degree? So just see, when you differentiate this mean square error, you get the one solution which is the optimum solution. But now you use the higher degree. Let's suppose you use the 6, you use the 7, you use the 8. So now when you start derivating of this, you get the many optimum values. Say you use the third degree, what the differentiation come, it's come the second degree. So second degree, how many points? There are the 2 points, so you get the 2 optimum points. So why we need, when we can use the square error, which is a standard way to use also. So this is the answer of the your second question. Now I hope you understand all the two question which earlier I not covered, but in this video I covered from the linear regression. Now move to the third question. That's first question, what is a bagging and a boosting? I want to ask in very short, what is the bagging and a boosting? So bagging, as you know, bagging is also known as the bagging or a bootstrap sampling is a one thing. So bagging is help us to reduce the variance in the model while keeping the bias constant, and boosting is another way of ensembling which can help us to reduce the biasness while keeping the variance is same. So bagging and boosting are the we can explain in one line is that. But when they ask what, explain the algorithm behind it. So let me explain you about first the bagging and then we come up to the boosting. So the bagging is, as already told, bagging is also known as the bootstrap sampling. So what happened here, you have one original data set, that is a D. You have the D is the original data set. You create subset from the D and you tell that is a D dash with the same dimension. Now we start build the different kind of a model on the D dash. Now suppose we do the D1 dash, we build M1. Then we do the D2 dash, we build M2. And suppose like this we build the many base learning model. That is the base model for on the D dash. Now take the prediction from every model and do the aggregation. And that is your the final prediction. That is what the bagging do. Let me repeat what the bagging do in the short. Bagging, we have the original data set, we create the subset from the original data set having the same dimension, then we build the model on that subsets. We have the lot of subset from the original data set, we build the different kind of a model on that subset, and then we take the prediction from every model, say M1 to MK, we take the prediction from PK to PK, P1 to PK, and then we aggregate these prediction, and that is the final prediction for our the model. That is what the bagging do. Now what the boosting do? So boosting is also known as a sequential process of ensembling. It is what, in the first step what it do, it creates the subset from the original data set and then it trained the model in that. Initially it gives the same weight to every data point in that data set, and then we train the model in that subset. Then we do the prediction by calculating the actual and predicted values, and then we calculate the error. Now once you get the error, now again you build the same model, again you perform the modeling on the same data set and calculate the prediction and try to reduce the error which you have already from the first point. Then you try to reduce that error, and like this you do in the multiple steps, and you have the multiple models. So what actually happened, your the final model which come is actually depend on your the previous models. That is the process of the boosting. That means the boosting algorithm work like that. All the models in the boosting is depend on its previous model. So what we are doing, we are making one strong model from the weak base models. That is what we do in the boosting. So let me summarize whatever we discuss about the bagging and the boosting. Bagging help us to reduce the variance. In the bagging, all the models work independently. Suppose we have the multi-core system and we have the multi-model. So we have the multiple models. So every model can train on one core because we have the multi-core system. So that this kind of model easily parallelizable. That is the one benefit we have. The next point is that the perfect example is a random forest. Random forest is the use the base learner, the base models are the decision tree, plus it use the bagging, plus it use the column sampling, and it do the aggregation. That is a random forest actually, as the example of bagging. For the boosting, what actually do? It is a sequential process. The every model which come, the new model which come is actually already depend on the previous model, because it want to reduce that error. And the perfect example is a GBDT. So this is what about the bagging and a boost. I hope you like this video. The all the three questions are clear. If you not understand any question, let me know in the comment section. And I hope you like the video. We'll meet you soon in the next video. After that, take care. Bye bye. Thank you to watch the video.